Morning. How you doing? Glad you guys joined us this morning. Good morning. Yes, I can. Let me see how I can do that. What class period are you in? Do you know? If you tell me what class period you're in, I can post that for you. Actually, I've got all the class codes somewhere. Yeah, I've got them down here. Hold on. Sixth period? All right, so this is your class code for sixth period. All right, there's your code for sixth period. Good morning, good morning, good morning, good morning. Morning, Jonathan. You're welcome. All right, those of you guys that have joined the stream, which is quite a few of y'all this morning, we're going to be going over the ideal gas law stuff. So if you want to go to Google Classroom, the very first link that I just posted on there is some group work stuff. And this is actually something we would be doing in class, but we're not because we're not in class. So I would have separated you guys out into groups and then had you work on these, and then we would have came back together. But every group would have done every other group's work also, and then y'all would have shared your work together. It's actually pretty fun, especially over an hour and a half. So if you want to go ahead and open this link right here on Google Classroom, and there it is. And what I'm going to do is I'm going to write down this question on the paper so we can see it and I can work it out together with you. No, we're not going to do all of them. We don't have time to do all of them. We'll probably do, I don't know, maybe 4 of them. And if you guys go through there and there are some that you would like for me to work out and I'm not working them out, then just let me know and you can choose them. And I'll work them out that way. There's a lot of problems in there. There's like 8 or 10. All right, so here's the first question. It says, how many moles of gas are contained in 890 milliliters at 21 degrees Celsius and 750 millimeters of mercury? Okay, good morning. So, how do we work this out? This is a PVnRT question. Okay, so we're going to use PVnRT. We're going to use PV equals nRT. Do we do it on paper and take a picture and then turn them? These are not questions that I'm making you do for homework. These are just practice questions. Because you have a quiz that I'm going to be giving out tomorrow morning. And it will have questions very similar to this. So I would definitely pay attention to what I'm doing today. that you will have to write on paper, and that you will have to turn in. Actually, that's going to be on Google Forms, so there won't be anything to turn in. You just have to fill out the form. In every class period, we'll have a different quiz, which is why it's taking me so long to make it. Still not done yet. All right, so let's go back over what these units mean, okay? This is pressure. All right, that's pressure. And it can be in ATM, it can be in millimeters of mercury, it could be in torr. Those are the three that I gave you. This is volume. And that's going to be in liters, or it could be in milliliters. So there are 1,000 milliliters is equivalent to 1 liter. Mole. The R value is a constant. And the constant for ATM is going to be 0.08206. The constant for millimeters of mercury or torr is going to be 62.4. And T is temperature. That is going to be in Kelvin. So that's what all those things mean. And in the question, it says how many moles, right? How many moles? So what we would do with that is we would go ahead and box that. How many moles of a gas are contained in 890 milliliters? So we'd circle that one, that's important. At 21C, that's important. And at 750 millimeters of mercury, that's important. The rest of it, we can just cross out. Okay? So when you solve for a question like this, that's what you're going to want to do, is cross out the things you don't need, box the thing you're looking for, and circle the things that you don't have. How do you know the constants, like the number for them? Oh, so these constants right here, I will always give these to you. How do I know them? Because I memorized them, because I use them all the time. But these values are not calculated. These are actually found in experimentation. And I will post a video on how that was done at some point. Just depends on how much time I have. Probably won't be this week. It might be next week, but it is kind of cool though. These values originally came from this setup right here. So what do you notice about that? You notice that this is the combined gas law, PV/T, with the N. And the only thing that would connect these two different situations is a constant, meaning that there's a variable in the middle that sits there that kind of controls the flow between those two sides of the experiment. That's where that comes from. So that value right here, this R value, is determined experimentally. But what we found is that it remains a constant because it doesn't change. So that's how we actually created that value. Whoops. There we go. Okay, so back to this. All right. So let's go back to the question. What are we solving for? We're solving for moles. So we're going to have to isolate moles in this equation right here. Okay? So let's rewrite the equation. That's what we're trying to solve for, right? So in math, we use the term isolate, right? So if we're trying to isolate the N, we're going to divide both sides. I bet you are. Is that Brian Eru? Gotta be. So we're going to divide both sides by RT. Okay? And when we divide both sides by RT, then we get PV/RT equals N. Okay? So we get PV/RT equals N. Now, before we move any further, the next thing that we do is we write out our variables. So we have P, V, N, R, T. So the pressure value is what? Where is the pressure value? Pressure value is going to be millimeters of mercury. Remember, because I said right here, it could be ATM, millimeters of mercury, or torr. So it's going to be the millimeters of mercury right here. So what we do next to P is we write 750 millimeters of mercury. Okay. What's our volume? It's in milliliters. So it's 890 milliliters, but it has to be calculated in liters. It can't be calculated in milliliters. So we need to take 890 and divide it by 1,000 because there are 1,000 milliliters in 1 liter. So it'll look like that. The other way you could do this too is instead of doing this, you could just move the decimal place over 3 spots. All right, so we're going to get 0.8900 liters. The N value is what we're looking for, right? That's the moles, okay? So this is our N, and we don't know what that is, so we're just going to put a question mark down here. Our R value, because it's in millimeters of mercury, is going to be this guy right here, which is 62.4. There's your units. I'm not so concerned about units with you guys. If this were pre-AP, I'd be all over you about it, but it's not. Units always help you solve questions, especially in science. And then the temperature. What's the temperature? 21C. But one of you guys comment right here, what should our temperature be in? What does it always have to be in? It's 1 letter. Yes, this is going to be on YouTube. You can always go back and watch it. What should our temperature go to? There we go. So very good. It's supposed to be in Kelvin. Perfect. Okay. There we go. All right. So what we're going to do down here is we're going to take 21C plus 273, and that's going to give me my Kelvin temperature. Okay. So that's going to be 294 Kelvin. Good job. Okay. So now you have all your variables written out. Now all we have to do is just plug it into that equation. Okay. So our pressure is 750. All right. Our volume is 0.890. Our R value is 62.4. And our temperature is 294. And that equals N. I think I have this worked out somewhere. Let's see if I can find it. Man, this computer just, I swear to you, forgets what it's doing. Oh well. Let me see if I can find a calculator. Okay. So we've got 750 times. Why is this not running? Got 750 times 0.890 divided by 62.4 divided by 294. Okay, 0.0363. So the N equals, how many sig figs do we have? 3 sig figs. So it's going to be 0.0364 mole. That's your answer. Not a lot of moles there, but it is a gas, so. All right, where are we at? Scale 1 to 5. 1, I don't get it. 5, I'm really good. The next problem won't look quite so messy because I'm not going to put the equation in the middle of it. A 0.5. Okay. All right. Cool. 5. Good, Siri. What's up, Josh? 5. Good. 3. Somewhere in the middle. All right. Good deal. All right. Let's do another one. Next one is calculating the volume. Let me see if I find a little bit more of a difficult one. Yeah, let's do question 4. That way that'll give you guys a chance to do the same type of problem. Okay? So we're going to do question number 4. It's going to be on page 2 of that document that's on Google Classroom. If you just joined us, if you go to Google Classroom, so go to Google Classroom. It's that first link that's on there right here. It says PVnRT group work. Go ahead and click on that. And then scroll down to question 4. And we're going to work on question 4. Okay? So I'll leave that up there for a second if you want to write it down. If you're not. Good morning. All right. So here's our problem. A student collects 425 milliliters of O2 at a temp of 24 C and a pressure of 0.899 ATM. So as we're doing this, as we know this is a PVnRT question, what you should do right away is go ahead and write out PVnRT. Just like that, okay? So that's how you should start your question off, every time. Now, as you go through and you read the question, if you come up to a number in a unit, go ahead and write that down where it's supposed to go, all right? So it says a student collects 425 milliliters That's important, right? That's a volume. So we're going to write that next to the volume. These are good question taking strategies, right? Of O2, okay? At a temperature of 24C, so that would be a temperature, 24C plus 273, all right? That gives us to 297 Kelvin. Okay. And a pressure of 0.899 atm. Okay, 0.899 atm. So pressure of 0.899 atm. It says how many moles of O2 did the student collect? So we don't know the mole quantity. And our R value is associated with our ATMs. So our ATMs, if you remember, these are going to be our R values, right? These are R value. For ATM, it's going to be 0.08206. And for millimeters of mercury torr, it's going to be 62.4. So since we have ATM, we're going to be using this one right here. So we're going to take this number and put it where R is. By the way, some R values you will see will be 0.08210, which is fine. I just prefer that one. But 0.8210 is fine as well. You're not looking at that big a difference in the number. That's just how I learned it. All right, so what are we solving for? We are solving for N, the mole quantity. This is exactly the same thing we just solved for before, except this time I'm going to let you guys solve for it, okay? I should do a Q&A with you guys. That'd be kind of cool. So go ahead and solve for that and see what you get. I'll give you guys a couple minutes. Hey, don't forget to turn your milliliters into liters. There's your answer. Three 6 figs. It's 0.0157 would be your answer. Moles. Jonathan, I think you forgot to divide by 1,000. So if you take the volume right here, if you leave it at 425, that's not right because it's in milliliters. It has to go to liters. So you divide by 1,000 to get to 0.425. Okay? But you're spot on, dude. Anybody else get that answer? All right, do you guys want one more or is that enough? $9.38. All right, good. Jonathan? All right, I'm gonna upload that quiz tomorrow. It'll be due Friday night or Friday afternoon. I can't remember what I put online. And then you already have those 5 questions that are already on there, and those are due by Friday as well. And then the FET simulation that I was gonna have you guys do got canceled. At least I canceled it. Nobody else did. I canceled it. So you don't have to do that. So your last assignments are going to be this quiz and that homework, okay? That's already on Classroom. So you guys have a great day. If you need anything, I'm around all day on email. Lord knows I answered a ton of emails yesterday. So if you need something, let me know. You guys have a great day. Bye.